um, that we have here on PRTG. So we have the device when we set up a couple of sensors in order to monitor QoS. First off, we have the HTTP. So the HTTP has been monitoring the network for the past 2 days, and you can see the traffic and loading time for the packets, and the loading time is introduced. It has intrusive traffic with it, so we have a video stream always running in order to capture these loading time. That's for the HTTP sensor. Here, as you can see, these are the values that the loading time takes for the video. And here, the next one we used is the SNMP traffic, which basically takes packets, traffic in, traffic out. It has been monitoring the traffic for the past few days as well, but here you can't see because this surge happened when there are multiple video streamings involved. The huge surge happened to the network, which is actually a QoS bottleneck or bandwidth bottleneck, which needs to be adjusted by the service providers. And here, as you can see, we this is the normal traffic without any intrusive traffic or any video streaming. And then we applied video. We had video streams working, and then when multiple video streams were introduced, that happened a huge spike in the bandwidth, and it actually caused the device. It almost caused the device to freeze. Um, that's for the SNMP traffic, as you can see. And here we're back to normal traffic. And I also adjusted it based on this sensor. We adjusted a couple of notification triggers in order when the total traffic reaches 1,200 megabytes per hour, we need to send an email to the to the to the service providers or to tell them that there's something wrong with the network, there's a bottleneck happening. And there's also, since this sensor is very important, when the sensor state is down, we need to also notify the service providers because it provides relevant data or information, very important data to the service providers. Third sensor we used is packet sniffer. Packet sniffer has also been live for 2 days. Um, Here, as you can see, the incoming traffic. These are normal traffic, and then we introduce um, video streams. But here, as you can see, there's the www protocol is the one responsible for protocols that use for resources that use HTTP protocol. So here, when the huge surge here happens when it's fetching video streams. So the huge spikes happen when we're fetching multiple video streams. When multiple video streams are getting opened, a huge surge happens. And here, when the video streams started, we enhanced the quality of the video streams when we used 4K quality. The various megabytes per second increased. Various is the traffic income coming from TCP and UDP. This video streaming uses TCP and UDP. Then that's why the traffic there is high. And after multiple video, when we introduced again the multiple video streams, this spike happened, which you can see it here and the other sensors. It's all interconnected. All of the sensors had this huge spike when multiple video streams were introduced to the network. Um, and last but not least, of course, the QoS one way, one of the most important sensors for QoS. Um, we have here, it's been monitoring the data for 2 days as well. Here you can see the minimum value is 0 ms for jitter, and we're gonna explain this. Okay. So first off, we have the live data. Live data shows we're not already running a video stream right now, but we can see here from the 2 days. The graph needs to be a bit zoomed in. It's not visible here, but as you can see, when the packets are received, here it can calculate jitter. Jitter is the delay. Packets out of order is the packets that arrive with like it doesn't arrive with when it's specified for queuing, it arrives out of the queue. That's why it's packets out of order. Packets duplicated if a packet is received, but it has like a malfunction, so it's duplicated, or the same packet is sent twice. Packets corrupted is the one I meant to explain. That's the packets that arrived but they have certain corruption in them. Packet delay variation max is the packet when the packet is delayed and it arrives a bit later. So there is always this average value that like have because every packet has delayed, since there is always going to be a bottleneck. These measure actually the things that could go wrong with your network, which is really good for QoS. And as you can see, packet loss here most of the time is less than 1%. And packets out of order, it's always the packet delay variation max, the ones that are moving along with the jitter, because the jitter and the packet delay variation max, as you can see from the live data, are the ones that are always going to change. Since we don't have any video streaming working, we have it's still at 4 milliseconds. But as you can see from previous data, when there was video stream going on, just give me 1 second. Uh, Here, as you can see, we got to the part where there was video streaming running. The variation of the packets is shown here, and the jitter is maximum at 7 milliseconds, which shows that the network is actually stable. It doesn't have any like huge spikes or surges that's happening. And we also had like no triggers for this, in order if because there are certain values that if they're too high, then that's bad for the network. So we added a couple of notification triggers as well. When a jitter goes for above 500 for 30 seconds, which is really bad for a network, we send an email push notification to the admin. And the packet loss is as well above 50, which happened once here when there was this huge surge when we applied like multiple video streams. When it's above 50 for 60 seconds, we'll also send an email or a push notification for them to the user. And all these sensors combined, and the QoS, there's something else in the packet sniffer. The packet sniffer also shows the top tokens and the top protocols. Here are the top IP devices along with the destination ports and amount of bytes it takes in the ports that they're connected to, along with the top tokens. Everything here is displayed. It shows the laptop. This laptop is taking most of the bandwidth right now. It's top top talkers are the IP addresses that are taking most of the bandwidth of the network right now, and that's it. Um, that's how we use to monitor the bandwidth. Thank you very much.